So here's the last problem, last video. It's a problem that you'll see many times throughout the school year before the AP exam and even on the AP exam. Finding the equation of either a tangent line or a line perpendicular to the tangent line at that point that here we have listed. But the important thing to remember is that when you're trying to find the equation of a line, you need, so the equation of a line, I'm going to label that EOL, equation of a line. You need two things, okay? You need a slope and you need a point, okay? So the slope and the point. In this case, we're already given the point, 2, 3, and the slope, again, here we have perpendicular. One other thing you need to remember is that the perpendicular lines have slopes that are, I did this totally the long way, negative reciprocals, okay, negative reciprocals. Okay, so in other words, if slope 1 is, let's say 4/5, then the slope of the line perpendicular, so if these two are perpendicular, then this slope would be flip the fraction over but change the sign. So one's negative, one's positive, two slopes, negative reciprocals. So that's all you need. You need the slope and a point. And the slope would be y prime at 2 in this case. So the slope that we need is y prime at 2, actually the line perpendicular, so we need the negative reciprocal of y prime at 2. So the first thing, though, that we need is to find y prime at 2. Y prime is easy to find if we know our rules, 3x squared plus 1. Well, y prime at 2 is equal to 3 times 2 squared plus 1. So 3 times 2 squared is 3 times 4 plus 1. I concentrate on everything, okay? I don't want to make any silly errors. 12 plus 1, so we get 13. So the slope of the line tangent to this curve is, at that point, is 13. Okay, drawing a little picture here, it won't take long. 2, 3, 1, 2, 3. If the slope of the tangent line is 13, then it's going to be really steep right there. So let's say that's a slope of 13. And then we have this perpendicular line to that. So the slope of this line would be negative 1 over 13. So the slope here is negative 1 over 13. Much easier for me to visualize what's going on when I draw a picture. So at the point 2, 3, and who knows what this curve looks like? We don't know, nor do we care what it looks like. But if by chance it looked like this, great. So it comes up like that, and maybe it goes over like that. I don't know. But nevertheless, we have the slope of the line perpendicular. That's our negative 1 over 13. We already know the point. And so we just use this formula, this, I should say not formula, but point-slope form of a linear equation. And that's what we're trying to find. The equation of the line perpendicular, okay, to the tangent to the curve at 2, 3. So we just replace the y1 with the y-coordinate of the point. We replace m with our slope of this orange line, and the slope of the orange line is negative 1 over 13. And then we replace our x1 with the x-coordinate of that point, which is 2, and we are done. Okay, that's it. All right, make sure you know how to do that. That's going to be on just about every test. And I have a few problems that I'd like you to do before you come to class. Bring these with you to class. You can check the answers in the back of the book. Send me an email if you'd like me to make a video on those, but I'm going to assume that if I don't get any emails, that you guys know how to do those. And so send me an email as soon as you can if you want me to make a video on those. Otherwise, I will see you in class. Have a great night.